Hello everyone, welcome back to our channel. This is series 4 which deals about architecture and frameworks for agentic AI, that is mainly covering cognitive architecture and multi-agent system. Come, let's go into the video. The first one is about cognitive architecture for agentic AI. So this actually provides a blueprint for a structure and then functions of an intelligence agent's mind. So they specify the core components of cognition. So the key idea why this architecture has been created is because it is created for a unified theory of cognition that can be implemented computationally. And the focus is on how different the cognitive function would be, maybe a memory, learning, or a decision making integrated together. Now, this cognitive architectures are SOAR, that is nothing but state, operate, and results. So this was developed by Alan Neville and John Laird. And their core principle was where all the cognitive tasks are a search through a problem space. So now there should be some key components which satisfy this SOAR. First is working memory. So this will be representing the current state, and procedural memory represents the long-term memory of if-then rules, and then comes the decision cycle which will propose, evaluate, and select operators to apply to the state. And finally, the learning mechanism that is being used is chunking. That is, when this SOAR reaches an impasse, that is, doesn't know what to do, it will solve the sub-problem and learn a new rule. That rule is nothing but the chunk we call it as. It will be learning a new chunk to handle similar situations in future. Next is about the cognitive architecture, Act R. So this is nothing but it is a adaptive control of thought rational. So this was developed by John R. Anderson. So the core principle of Act RIR is nothing but it is a theory how human cognition works, aiming to model a human performance in cognitive tasks. So these are all the near future development which we are going through. Now already we are ending up with ChatGPT, multiple AI tools that minimizes the human intervention. So these are the cognitive architecture which is even really going to analyze what a human cognitive can think and what it can do, what it can decide. So there is no human required for a performance of industry to be, so that the this architecture itself will detect everything as human does. So this consists of a declarative memory. That is, this will store the facts as a chunks, and procedural memory will store knowledge of how to do things like production rules. And then comes the different modules, that is specialized component for perception, that is either vision or audition, and then the action. Here the mechanism is based on sub-symbolic computation, that is the activation levels of chunks. This will determine which information is most relevant and which rule to fire on. Alright, so moving on to the next cognitive architecture, that is LIDA. So here it is nothing but Learning Intelligent Distribution Agent, which was developed by Stan Franklin. So this core principle is completely based on global workspace theory of consciousness. So there should be some key features that addresses this architecture. That is nothing but it is a comprehensive system level model which keeps covering a large portion of human cognition. Next comes different cognitive cycles. So these are perception, workspace, attention, and action selection. So the perceptions are nothing but it is the one which senses the environment. It can be a dual environment, single environment, and next comes the workspace. So this is nothing but it is the information which is brought together for a conscious processing. Then comes the attention. So it is a spotlight that focuses on most relevant information. Then comes action selection. So this is going to choose the next action that has to be taken. Then last comes some learning mechanism that has been followed in LIDA, that is, it employs multiple learning mechanism. So complete cycle follows different learning mechanism and doesn't stick for one particular chunk. Next comes the multi-agent system MAS. So this is nothing but it is a system that is composed of multiple interacting and autonomous agents. So this gives a complex problem that can be solved by dividing them among the different groups of agent who can work together. So for this, we actually need a characteristics. One is every agent has an incomplete information. So they are either capabilities for solving the program. So they don't have much information in their hand. And there is no control. There is no control for the complete system. And then if there is no control for this complete system, obviously the data will not be in a centralized channel. And then the computation will be asynchronous because there is incomplete information and global system control is absent and there is no data that has been centralized, and obviously computation will not be synchronous. So we'll be seeing the next kind of architecture in the next video. Please stay tuned for more information. Thank you.